Hello everyone, today we are going to calculate the problem number 10 from fundamental problems chapter 16, and it's from RChibbelerDynamics edition of static and dynamic. So the problem is about this crank OA rotating at angular velocity 12 radian per second in anticlockwise direction, and we have to determine the velocity of this piston B, and we also need to determine the angular velocity of this rod. So we know this information, and we will have to move to here. So we will start writing down the given facts. Is omega OA equal to 12 radian per second? Is in anti-clockwise direction, and VB value it's that we need to find it, and also omega AB value. We will start with vector analyzing. So we know the omega OA value, so we will be able to find VA value here. VA equal to omega OA into ROA. So that is 12 radian per second in kcap, and OA value is 0.3 meter up. That is why the values are positive. So for the multiplication of kcap and gcap is minus icap, and altogether this will have minus 3.6 meter per second icap. So that's VA value, and from VA value we can write an equation relating to VB value from that. So it's VB is VA plus omega AB into OR from A to B. So VB value is unknown, but this VB value will only move in one direction. So they will have only like J-cap value. So that is why VB only J-cap equal to VA value is minus 3.6 I-cap plus omega AB is unknown yet, and then that is in K direction, and that will have to multiply with the distance, but this distance will be in two components. The first component is 0.6 cos 30 degree I-cap and minus 0.3 J-cap. So that is from A to B. So that is A to B. That is why the components will be like this. I will rewrite this now. It is positive X direction, and that is negative Y direction. That is the resultant that is going for AB. So for simplification of this one, we will have to multiply. So that's why it's VB J-cap equal to minus 3.6 I-cap plus 0.6 cos 30 degree omega AB. K-cap into I-cap, it's J-cap positive, and so it's still positive now. And then for the K-cap into J-cap is minus I-cap, but as a result it will have only plus 0.3 omega AB I-cap. So now we will divide into two equations for different I component and J component here, and that will have 0 equal to, for I-cap it's minus 3.6 plus 0.3 omega AB, it's equation 1, and for J-cap that will be VB value here. So VB is 0.6 cos 30 degree omega AB. So equation 2, from equation 1 we will know the omega AB value, which is equal to 12 radian per second, and that is positive because it is in anti-clockwise direction. And from substituting this value we have VB value from equation 2, it is 6.235 meter per second, and positive because it is in upward direction. So that is in upward direction. So that is about vector analysis. We will move to scalar analysis. We will start writing the equation now. VB equal to VA plus V from A to B. So VB value, we will take its positive value, and then it's the omega into distance 0.3 meter, and that is onto the left minus x direction, and that will have to combine with omega AB value and into 0.6 distance, and that is in this direction 30 degree. It's you can refer from here, it is 30, and that is the right angle. So this angle will have 30 degree as well. So we will divide the components for I cap. It is omega AB 0.6 sine 30 degree, equation 1, and VB value equal to omega AB 0.6 cos 30 degree, equation 2. By solving this equation, it will have omega AB value 12 radian per second anticlockwise, and we will have VB value 6.235 meter per second in upward direction. So that is it about scalar analysis. So this is the end for this problem.